All right, here's a step-by-step breakdown on how to do this homework. Cosine, parent function normally starts at 1, so since our amplitude's getting stretched, it's going up to 2. Normally the period goes 2 pi, that hasn't changed, so I'm going to go out here and call this 2 pi. So by the time I get out here to 2 pi, comma 2, I'm back at the top, right? So I'll tell you what I'll do. I'm just going to label the axes. So this is 2 pi over here. Halfway through, I'm down at the bottom. That's at pi. And then here at pi over 2. And 3 pi over 2. So your graph should look like this. Alright, and then it would obviously turn back around. Alright, your amplitude is 2, basically it's the number in front. And the period is still the normal 2 pi for cosine. Alright. 4 times the sine, same idea. Sine still starts at the origin. So after 2 pi, it's still going to get back down to the origin. Halfway through, it's going to cross back through the middle. It hits the top here at 4, because instead of stretching to 1, it's going to stretch at 4 units. And it's going to go down to the bottom here at -4. So it should something like that. All right. Amplitude is 4, and sine's period is still 2 pi. All right, y equals -2 times the sine. All right, well, hasn't affected the starting spot. It's still going to be at 0, 0. Period is still 2 pi. The only difference is instead of rising up to 2, since it's a negative, it's going to go down to 2. Still crosses through here at the center. And then this. And they would technically continue on in either direction, right? Amplitude is always positive, so even though it says a -2 right in front, the amplitude is just the distance from the midline. Here's the midline it goes up to. Period is still 2 pi. All right, no big deal. Keep it on hustling. Half a tangent. All right. Tangent normally passes through the origin. Has an asymptote. I'm going to put it over here at pi over 2. Let's see. Use my fancy schmancy technology. There's an asymptote at pi over 2. We're going to have another one back here at -pi over 2. All right. Then we got at pi over 4, it would normally be up to 1, but since our amplitude, or since our we get affected by a coefficient of 1/2, it's going to be down here at 1/2 when it gets to pi over 4. And then -pi over 4, it's going to be at -1/2. So it starts to flatten the graph out a little bit, and that's how you end up. Something like that. All right, and then you can repeat it again over here at pi. That's going to go. Okay. And for amplitude and tangent, it's still undefined because it stretches all the way to the top, and your period has not changed. That is still pi. Repeats every pi units. Okay. Here we got a period change. So your amplitude is still 1 because there's no number in front, but the period for sine is normally 2 pi. So this one's going to be 2 pi over 3. So it still starts at 0. But when it gets over here, instead of that being 2 pi, Let's just call that 2 pi over 3. So then halfway, you got to cut 2 pi over 3 in half. Well, what I do is I think about 2 pi over 3 divided by 2 is same as multiplying by half. So that's like 2. 2's cancel out, and really it's like pi over 3. All right. Half of pi over 3. If you cut that in half, is pi over 6. So that's where this guy is. And then halfway in between pi over 3 and 2 pi over 3. Well, like there's a lot of ways you can think about it. You might want to change these all to sixths in your head. Here's 1 pi over 6, 2 pi over 6. So this should be 3 pi over 6. Can you see how pi over 3 is really the same as pi over 3 is the same as 2 pi over 6. So here's 3 pi over 6. And you can imagine how this is the same as 4 pi over 6. All right, so those are our benchmarks on the x-axis. And we just go up to 1, down to -1. So a nice smooth curve. Messing it up. There we go. Flip it down. Something like that. All right. And there you go. The key thing is, even though it doesn't look like it's any smaller, if you were to graph this on a graphing calculator, you would see that this one would be squished in a little bit. By changing the axis, I made it so that it's nice and neat. But really, this one, think about where 2 pi is. 2 pi is like all the way out here somewhere. So you get 3 different rotations in the time where you normally get, you would normally only get 1. Okay, so there's 1 rotation, there's 2 rotations, the third one to actually take that here. All right, cosine. Normally cosine would start up at 1, but since it's got a 4 inside with the angle, the amplitude hasn't changed, that's still 1. But the period, instead of being 2 pi, is going to be 2 pi over 4, which reduces down to pi over 2. So really, this thing's going to get up and down in pi over 2 units, right? So what I'm going to do is I'm going to go right here, label that pi over 2. So cut that in half, that makes this pi over 4. Cut that in half, that makes this pi over 8. And if you cut him in half, halfway between, or this is like 1/8, 2/8, here's 3/8. All right, let me zoom in a little bit because I can. All right, let's get a better look here. So this graph is going to start up here at 1 like it normally does. And it's going to dip down and get back up to the top. So halfway through, it's down here at the bottom of its journey. It's getting down, and it's getting up, and then it'll be getting down, and then it's getting up. Now, what's key here is all in how you label. The key is all in how you label the x-axis. Because as you can imagine, after pi over 2, you see it's gonna keep repeating, right? So really, it's doing that whole period, which is normally in 2 pi, and it's doing it in a quarter of the time. All right. All right. I'm just gonna walk through these next few. Tangent. Normally, again, the period is undefined as always. I'm sorry, the amplitude is undefined, but the period is normally pi, but this time we're going to divide by the 2 that's there. So that means instead of there being an asymptote at pi over 2, now our asymptote is going to come at faster than that. I have to repeat by the time I get to pi over 2. So looky here, if I start at 0, 0, when I'm back here at 0, 0, I'm at pi over 2 because I have to complete a whole cycle. So that means this is pi over 4 because I need to cut this in half, which makes this pi over 8, which makes this 3 pi over 8. Now you don't need these values on the unit circle, but it's good to label your axes that way. So again, I'm going to put another, let's see here, put my other asymptote in over here, and draw my shape. So halfway between where it hits crosses the origin and the asymptote, I'm going to be at 1. So halfway over here, I'm going to be at -1. And we connect the dots. Nice and smooth. The tangent graph is so hard to do. There we go. Okay. And then obviously we repeat. Let me go ahead and use my finger. Oh no. View, let me lock it. Lock this into place. All right. There we go. And we're going to group that. So now I can just scoot it over. There we go. All right. Still hustling. Last two, and then the back I think is actually really easy. Negative cosine. All right. Amplitude is still 1. The period would normally be 2 pi, but this time we're dividing it by 4 since that's what's in there. Simplify that, and that goes down to pi over 2. So that means the normal cosine graph would start up here at the top, but since we have a negative in front, it's going to start down here at the bottom. Normally the period goes to 2 pi. Now, since our period is cut down, it's going to repeat every pi over 2. All right, just for the sake of trying to be somewhat accurate, I'm going to make this guy pi over 2. Really, you can label your axes however you want. So that means I got to get up and down by the time I get to pi over 2. Which means in the halfway point, I'm at the peak. Halfway through that, I'm crossing through the center here, okay? Well, halfway between pi over 2, this would be pi over 4. And that's going to be pi over 8, 3 pi over 8. So let's just connect the dots. All right, so this is really smushed together here. All right, so your graph would look a little something like that. And obviously it would continue on forever. Okay. over here, all right, now we're combining it together. So here now I got an amplitude of 4. My period is normally 2 pi for sine, but I'm dividing it by a half. Well, dividing by a half is the same as multiplying by the reciprocal, which really means my new period is 4 pi. So really it's going to get stretched out here. So it's still going to start at 0, 0, but when I get over here, instead of being 2 pi, it's really 4 pi, which means halfway through I'm at 2 pi, and halfway through there I'm at pi, which makes this 3 pi. Now instead of rising up to 1, I got to go up 4 spots. I'm going all the way up to 4. And then halfway through here, I'm dropping down 4 spots. Let me move this. So we're dropping down 4, which takes me down here. So I swing up, swing down. And there's your graph of 4 times the sine, 1/2 theta. All right. Now the back, I think, is actually a lot easier. If we go on to the back real quick. There's the back. All right. Blah, 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 blah. They're asking me for the amplitude. Look, they give you the equation right here. There's your amplitude, 500. What's the period? Same as it always is for cosine, 2 pi. Amplitude, 500. Period, 2 pi. Don't make it harder than it's got to be. Right now, if you look at this one, all right, we're supposed to determine the period. Well, the period is, for sine, is normally 2 pi. Now, I believe they're actually doing, let me look at this one. I think they're doing it, okay. So, yeah, the period is 2 pi over pi over 6. Well, remember, dividing by a fraction is the same as multiplying by the reciprocal. The pi's are going to cancel out, and really you end up with 2 times 6, which is 12. So there's your period. Now, oops. Now, if you think about what this period represents, it's saying it repeats every 12. Well, every 12 what? Remember, this was getting affected by t. T is months. So your period here is really just a year. That makes sense. If you're talking about the weather in April, it's going to repeat itself every April, which happens every year, right? Now, what is the maximum high temperature, and when does this occur? This one's actually a little harder because we didn't talk a lot, well, we haven't talked at all, about what this 60 does to the graph. But normally, you know, the sine graph, actually, let me use, normally the sine graph starts at 0. But when you do this plus 60, what it really does is it takes that graph and it shifts it up 60 spots. So really now it's going to start here at 60. All right. And then everything else does what it's supposed to do. So the period is going to be 12. So at 12, I'm going to be back here at the center. It's telling me the amplitude, or the 25 is still the amplitude. That's how high I'm going to stretch up, right? So when I go up to the peak, I got to go up 25 off of the 60. So that's really going to take me to 85. And it's going to get dipped down 25 below the 60, which really takes me to 35. But sine still does the same thing it always does. It starts at the center, rises up, halfway through it crashes to the middle, so that's going to be 6. And then it dips down, it comes back up. So here at 3, and then at 9. So I'm going to reach the peak at 85 at the 3rd month, and I'm going to reach the low spot at 35 at the 9th month. So then my graph ends up looking like this. All right. So it says T equals corresponds to April. So if you think about, okay, April is here. Add 3 months to April. April's the 4th month, so add 3 more and you're in July. So the peak happens here in July. And that maximum temperature you can expect to be 85 degrees. All right, Centerville must be somewhere up north because it gets a lot hotter than 85 degrees here in Virginia. So the max temperature is 85 degrees, and that happens in July. All right, hope you guys enjoyed it.